Hey everybody, this is Larry. This is me going with Q4 of the bi-weekly contest 174, minimum edges toggles on a tree. Hit the like button and subscribe and join me on Discord. Let me know what you think about this one. So this one I was able to get in about 8 minutes, 9 minutes, and most of it honestly is just me trying to like off code, trying to prove this correct. But I would also say, I just want to preface this explanation and how I did it so fast is honestly just by doing a lot of problems. A lot of tree problems, well, I mean, obviously because this is a tree problem, so if you've done similar problems, you just kind of have an idea of the texture and the feeling about these problems that you have an intuition about it. I mean, and maybe you have to prove to catch up, and if I maybe was more YOLO, I could have just done it much quicker without, convincing myself, right? But the idea here is just recursion, and the two core ideas. One is just recursion, but I don't know if that's a useful idea to say because this is a tree after all. So maybe you're like, okay, well that's just obvious. But the other part is this idea that everything is forced, right? Because then now, let's say, and I don't want to spend too much time on proofs on this one because maybe it's like an exercise left at home kind of thing. But the idea here is that, okay, you have a tree, and I keep drawing binary trees because, I don't know, I'm just used to it, but you can, and really there are all these colors and stuff like this, but really all you have to do is mark nodes that are incorrect or correct, right? So let's say you have this one and, I don't know, this one and this one, right? And then, yeah, and then the idea here is that the core idea is that the idea behind recursion is that, okay, you're given a node, right? And the core idea behind this recursion is that given a node, if you have children that where you drew the edges, that means that that's going to be your shortest path. But, let's step back a second. You could go here. You know that this is a node and this node is incorrect, right? What does that mean? Well, if it's incorrect, that means that we think about it starting from the leaf. Well, if this is incorrect, there's nothing you can do other than to toggle this, right? And then now in a recursive way, now that you toggle this, and of course you stored it, and you have no choice, by the way, this is a leaf, right? Then now you toggle this, and then of course you toggle well, this one gets toggled, and now this is good, but then you can maybe think about it just chopping off, and then now you color this one in, right? And of course, you just kind of keep doing it, right? And then now, this one, well, this is now leaf because, well, let's just say we cut off these because we processed. This is the leaf, right? New leaf. And if this is a new leaf, well, there's nowhere to go other than up, right? And then so we color this. This is marked as good because now we flipped it. And then now this is, and then so forth. And that's basically the idea, right? If you kind of keep on thinking about them as leaves, and then you just kind of keep on popping up and then forced to kind of go up. I think the tricky part about this is kind of proving to yourself that this is the shortest. But really, it has to be shortest because you have no choice, right? There's only, all your answers for the minimal things are forced. And it's only not minimal if you flip the same color more than once. Or if you do like, I don't know, if you toggle like things for no reason, right? Like, I don't know. Actually, I don't even know how you would do it, but because everything's forced, then now, you can do this recursively pretty, relatively easy. I don't want to say it's easy, but my code is pretty short. Okay, first we construct an adjacency list. This is just standard stuff, and this is the entire code, right? Which is crazy, but this is the recursive function, and all this does is just saying, total, because I initially wrote it a little bit differently. Basically, you have this 0, 1, but it doesn't even matter. The question is whether this, what you want to return is whether this node is correct or not. And then here, if it's not correct, then you increment by 1. And then now you go recursively down to children. Remember, we do mod 2 because it just flips. Anytime you toggle, it's going to go from correct to incorrect or correct or incorrect to correct, right? So anyway, so then now if it's always greater than 0, that means that at that leaf, at that recursion, there's a force on the last edge going up, and as a result, well, one is that you put in the answer, but also that you put it in. And of course, if you have two children that forces a toggle, then they kind of cancel each other out, and that's where the mod 2 kind of comes from. And that's pretty much it. And this is basically if you reach to the root, and it doesn't matter which one you rooted at. I just say 0 by convention. If you still need to toggle, then well, you're screwed. So you return -1. Otherwise, you just sort, and sort is just because they ask you to, and then you answer. And as a result, this is actually dominated by this because it is the sorting. But yeah, otherwise this is just linear time, linear space, right? Regular recursion stuff. Yeah, and that's it. A pretty straightforward Q4, if you ask me, but of course a lot of it is based on muscle memory and trees and this idea of because if you've done enough of these tree problems, then there's this idea of you're kind of forced to do things because there's only one shortest path between every pair of nodes, stuff like that. I think also, other than maybe the edges and stuff like that and returning or whatever, this does remind me of another problem now that I think about it, where you have like coins on you have coins on each node or something, and you have to try to like even them out or something. And this is the same idea, really. You can think about it as yeah, except it's over 2, which technically you could say is under the XOR space if you really want to think about it that way with respect to moving coins. But that's like just mumbo jumbo, really. But yeah, that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve it live in the contest now. That's such a, I don't know. That was so hard for me. Real guy, wait quickly. I mean, I had a typo that cost me like 10 minutes. So maybe that's it. But and then, I don't know. I was just way off on that one. Like a lot of silly things. All right, let's look at Q4. Minimum edge toggles on a tree. Now it's just a tree. You're given 2 binary strings, start and target of length. And for each node, start X is initial color. Is it always 1 and 0? Okay, yeah. So only 2 colors. Pick an edge and toggle both. I guess everything is forced, right? So that seems pretty straightforward. Maybe. I don't know if that's true. I mean, I think this is pretty straightforward. Maybe. I don't know if it's actually true. Alright, and then now it's impossible. Okay. Then it's just about, well, minimum is still tricky. I guess maybe it's not trivial, but So something like that, right? And then it just becomes will I ever? I guess you can toggle an edge 3 times. Well, not same edge, but toggle 3 edges. If it makes sense. Okay, what's the recursion? Okay, you have to leave. I mean, the cost is straightforward, maybe. Was this LCA? I mean, it's still, I think it's straightforward. I just have to be careful. I think this is one of those problems. Because it's always LCA. So in that sense, yeah, okay. Oh, I have to keep track of the edge indexes, so I have to be a little bit careful. Right? Yeah, whoops. Okay, but okay, I have to fix this. Okay, so you have recursion, you have this, right? So then now, maybe. Okay, if there's an edge. I mean, okay, if there's a node, what does that mean? If there's a node, that means that we have to do this edge, right? And okay, so then now it is just this mod 2 then, right? Because that means that we flip the edge. Maybe that's it. Is that it? Maybe not. We'll have to do the -1 case, but this is a way of -1. All right, we got one answer right, so that's good. Okay, now, but why is it at 5? Oh, I'm just returning everything. Whoops. If r is greater than 0. Alright, so that's it, right? YOLO submit? I may be missing some stuff, but okay. Yeah, I mean, I knew I was close, to be honest. Because the idea was, well, the core idea is that it's forced, right? So it has to be, so I was just trying to figure out like the right forcing function, if that makes sense. Thanks for watching, everybody. Hit the like button, subscribe button, join me on Discord. Let me know what you think about this problem, this contest, everything in between. Stay good, stay healthy to your mental health. I'll see y'all later and take care. Bye-bye.